Okay, we're going to continue with another example of calculating left and right hand limits at different points. So if this is the graph y equals f of x, then I want to find the left and right hand limit at x equals -1, x equals 0, and x equals 3. So first let's figure out left and right hand limit at x equals -1. Okay, so again, the superscript means the left-hand limit as x approaches -1, and the superscript plus means the right-hand limit as x approaches -1. So as x approaches -1 from the left, when I'm looking at this curve, the only part of the graph that's between or to the left of -1 is right here, and you can see that the y values are approaching -1, so that tells me the left-hand limit is -1. Now, if you look at the part of the graph approaching -1 from the right, the y values are all the same, they're all 0, so that tells me that the right-hand limit is 0. And notice that the left-hand limit is not equal to the right-hand limit. It should be clear because there's this jump from -1 up to -1 there. Now if I want to calculate the limit as x approaches 0 from the left, then I look at the points just to the left of 0, and I see that the y values are 0, which makes sense because this function is constant. It's 0 between -1 and 1. And then in this case, the limit as x approaches 0 from the right is also 0, because when I look at the values just to the right of 0, this function gives me a value of 0. Now finally, as x approaches 3 from the left, the limit as x approaches 3 from the left, here I'm looking at the values just to the left of 3, the y value is approaching 3. And then if you want to figure out what the value is as x approaches 3 from the right of f of x, well, you just look at what values just to the right of 3. Here the function is also 3. It's a constant function, x equals 3. So in this case, the left-hand limit and the right-hand limit are equal.